Welcome to my Python YouTube channel, DESI ASTRO, and in this Python tutorial you are going to learn about calculus using Sympy package in Python. So basically our objective is to learn that how to evaluate limit of a function as x tending to a or any number. So let's do it. And this is like one of the important thing in your calculus, basic calculus, to evaluate limit the function at any point. So let's find it. So for that, import some library. So import Sympy, and from Sympy import ASTRO. Okay, so this is used for symbols. So what you can import some symbols, say x equal to say, symbols, and you define as a character x. Now you can see that your x symbol has been created. You can also define a, b, c as a constant. Definitely you can to give a space and give their character. So you can see that every symbol has been created. Now we have to define a function. Okay, so define your function of fx. Now for that, you give f of x equal to, you give any function from your x abc. So I will give simply say sin x by x, and for limit I will give, say you want to give your limit, or give limit equal to limit, and give your function of x you want to give with respect to x, and you want to evaluate function at x equal to 0. So limit at x equal to 0. Let's see what limit is returning. Okay, so you can see that here is your limit, and this limit you are going to evaluate using a Sympy package. Okay, so here you need to evaluate your limit. Okay, so for that type here limit dot do it function, and it will return. So you can see that sin x by x gives your value equal to 1. Okay, so you can print limit is, and then limit is your 1 for this function. Limit of f of x as x equal to 0. Okay, so this way you can do it. You can also modify it to this limit at any point. Say you want to give it at 10, and then so sin 10 by 10. So it will like give expression. So I'm putting just here 0, and then we are turning our limit at x equal to 0 is 1. Now we will try some harder expression. Okay, so try some harder problem. Okay, so I've given a heading, and then we like look for some tougher problem. So here is a question. You can see here it is a JE questions. Okay, so you can try this one. X cube cot x minus 1 by cos x. So this you can try. Okay, so we can try this limit. Okay, so you can just define your say expression as x cube cot x. You can define here x cube and then into cot x and then divided by 1 minus cos x. 1 minus cos of x. Now check. Okay, so this time your limit is this and let's run it. Okay, so the value is 2. Now check for the answer what it is returning the answer. Okay, so you can see the answer is 2 and our answer is also matching. So our way of doing limit is correct. Let's do some more problems. Yeah, you can try this one, or maybe you can try this one. Square root of 3x minus a. You can try here. S cube RT of 3 into x minus what it is a. So minus a. Okay, so 3x minus so 3x minus a, then minus s cube RT of x plus a, and then divided by whole of x minus a. So there is no symbol of okay, so we have a in our directory. Okay, so now let's run it, and you have to give it x equal to a. So now run it. So you can see that there is some mistake happening here. You have to divide by whole. Okay, so we have to evaluate this expression. Now let's run it. At x equal to a. Okay, so our value is coming root 2 by 2 root a. So basically if you multiply above and below by root 2, then it's come 1 by root 2a. So the answer is 1 by 2a. So it is correct. Now you can try this one, exponential. Okay, so for that change your expression and goes to exponential of 1 by x, then minus 1, close it, then divide it, and then same, you will just copy it. Just type it exponential x and then plus 1, and we have to evaluate at x equal to 0. So run it. So we have to evaluate this expression. I think it's 1 by x. So just type here 1 by x. Okay, so this limit we have to evaluate at x equal to 0. So now run it, this program, and you can see that it is giving value equal to 1. So let's check it. what is the value of this answer. So it's 1. Okay, so there is some error, so we have to like evaluate at x equal to 0 plus and 0 minus. So limit does not exist for this expression, but for x equal to 0 plus it is coming at 1. So you can see that for 0 it is coming 1. So at x equal to 0 plus our limit is 1. So it's correct. So I hope you got the idea that how to. So you can do one thing. Okay, so you can do one thing. You can see that there's like 0 plus. So you can, if you want, you can give it as a say minus, then run it. Okay, you can see that your limit is like at 0 minus, then run it. Okay, so it is minus 1. So you can say that at x equal to 0 the limit does not exist at 0 minus. You can also do it at infinity if you want. So for that just type 0 0 and run it. So x tends to infinity. Let's see how it is coming. Okay, it's 0, and if you add plus infinity, so if you do it plus, then type it at minus infinity. Okay, so the limit has been extended to minus infinity, and now check it. So the limit is 0. So this way you can evaluate your limit for 0 plus and 0 minus, and you can give your left limit and right of that point. So this way you can do. So just copy it here. Or maybe you can just give it here 0. It's 0 plus, and then same thing you can copy here. And then you can give here 0 minus. So this goes from left, and then limit dot do it, and here. So you can see that the right limit is 1 and left limit is 1. So the limit of this function is not going to exist at that 1. So I hope you got a clear idea that how to evaluate your left limit, right limit from a point towards left and towards right, approaching the number. So thank you.